Just kidding.
Hey guys, what's happening? Thank you for tuning in to this Intellic Integration live stream. And today we're going to be with ITG Technologies, and we're going to be taking a look at Sorba AI. So here's Sorba AI, simple, complete enterprise IoT solution. So if you guys are interested in that, stay tuned for this entire live demo. As always, we are here with Walker Reynolds, 4.0 Solutions Architect. Walker, thank you.
Howdy, howdy. Thanks, man. I'm super excited. I'm super excited about this demo because this is the first time that most of our audience is going to get a chance to peek under the hood of Sorba IoT, which we talk about all the time as a best-in-class solution.
Yes, yes. And we have Aldo Ferrante with ITG Technologies. Aldo, thank you.
Thanks for inviting me.
All right, guys, I just wanted to say that this podcast is powered by 4.0 Solutions, and a special shout out to Mohammed Atif, who is in the live chat. I promoted him as a moderator for jumping into the stream and to engage with you guys. So I just wanted to get that out of the way. So Aldo, if you want to take it from here, give us the rundown of Sorba IoT platform and how it can, provide value to in industrial 4.0, digital transformation, machine learning, AI, let's do it, man.
All right. Well, thanks, Zach. Thanks for inviting me. Thanks for giving me the platform today to talk about Sorba. Everybody, I'm assuming, can see my screen. What I wanted to talk about is really that Sorba platform is a suite of applications that is designed specifically for industrial applications around the whole idea.
Aldo,
yes, sir.
Are you sharing your screen? Are you sharing your screen?
He's going to have to share his screen again.
Okay, sorry about that, guys. Let me just make sure.
That was my bad. When I shared my screen at the beginning, it took over control of your screen share.
Okay, let me open that up. And let me see here.
Thanks, Walker.
Man, good.
Share my screen.
Dude, what do you think about the beard coming in? Thank
you,
Aldo.
How's it now?
Oh, looking beautiful. We see your PowerPoint of tools in the belt.
All right. So I want to start off with this slide just to give you an idea of the different applications. As I mentioned, it is specifically designed for industrial applications. As you know, there's a lot of IoT platforms in the world, in the industry, and a lot of them focus on different verticals, but we specifically look at machinery, industrial equipment, both in the predictive maintenance side of the solution, as well as the process optimization. So whatever your goal is to use IoT and to use industrial artificial intelligence and machine learning, the idea is to build this entire pipeline from the source, which is typically your machine, to the end result, which is some type of either dashboard for digital visualization or some type of prediction, whether you're trying to predict machine uptime or downtime, or predict performance, whether you're trying to optimize for meeting certain objectives like increase yield or increase efficiency or reduce fuel consumption. Whatever your motivation or your objectives are, our platform can address many of those requirements. And so it really consists of these 6 applications. The IoT platform itself is the core, is what we call the operating system of the entire Sorba platform, and it's where everything comes together. So everything gets ingested into the platform, and it leaves the IoT platform either to a dashboard or to some type of machine learning agent that is doing some type of predictions. The SDC is the edge platform. One of the very important key components to the Sorba platform is that it is designed primarily around an edge platform. And edge means that you have some sort of compute inside your production area or next to the equipment or machine where it's collecting information as well as predicting some type of an event. So having the edge ability does a lot of things that will help to enhance the system. First of all, you don't require the cloud in order to make an action or prediction. A lot of the collection and the prediction, as I mentioned, is done on the edge. So therefore, the dependency on the cloud is minimized. And the cost of both transferring that data, processing that data in the cloud becomes, in some cases, doesn't become optimal. So having the ability to do things on the edge is very, very important. But if you want to do strictly cloud-based, the ability for Sorba, it's very flexible in that sense that you can either do only edge or only cloud or a hybrid of both. That's one of the advantages that what we found is very exciting about Sorba. The Big Data Historian is a time series repository. It's very typical to most historians that you see out there. The biggest difference with our historian is that it is very scalable. It's based on big data. There are two types of storage systems that are on the platform, what we call our cold and hot data. Our hot data is built around the Cassandra open source. That is a very scalable repository, and it's used to really build out globally and very, very wide data repositories for storing any type of data. Cassandra is used quite a bit. It was developed originally by Facebook. Netflix uses Cassandra to host and to store and provide video content to their customers. So we don't require, the Sorba platform doesn't require a hosted Cassandra. When you buy the platform on-prem, it comes with its own standalone Cassandra cluster. The cold data is using the Hadoop data clustering system for its processing. So any type of processing of information for machine learning, that's done on a Hadoop cluster. The management platform itself is really the key that we see as a gap in the industry today. Having someone do their own machine learning models, if you're a Python or R developer and you're developing some machine learning algorithms, typically when you develop those algorithms, you have to manage them. You have to find a way to, how do you integrate them to the factory floor? This is really the key. A data science project from a machine learning practitioner, they're going to have to build all that piping, all that data pipeline, and then they're going to have to manage that algorithm, and they're going to have to retrain that algorithm. That entire management piece becomes not a problem when you're talking about 2 or 3 algorithms, but when you're talking about thousands and thousands of algorithms on a typical paper machine that we're currently engaged with, there's several thousand algorithms on a single section of a paper machine, converting line, and some of the other sections, it could be almost over 10,000 different algorithms. So you could imagine trying to manage that many algorithms, that many agents, becomes a really total cost of ownership nightmare. And digital twin is really another version of the machine learning platform that allows you to create predictive models, digital models of your process. And what do you use them for? We'll use them for all sorts of things like process optimization, to do types of what-if scenarios on your process. Very, very helpful. So I didn't want to go too much into the PowerPoint. I just wanted to give you a quick overview. And then one last slide I'll show you before my overview slide is the edge device. One of the other key things that Sorba offers, which I thought was really exciting, is the fact that it's self-contained with all of the communication drivers to talk to your devices, to your PLCs, to your IOs, to your drives. So you don't need something like a Kepware or any type of additional automation layer to connect to those devices. So things like Ethernet IP, Profinet, Modbus TCP, as well as TwinCAT from Beckhoff, and about a dozen or so different other drivers that is offered on the platform. But it's very scalable. So if you can imagine, you take, for example, a standalone machine, compressor, or a pump, or any type of skid device that you want to be able to provide intelligence that is built into that system, that SDC is a Linux-based OS that could run standalone on a compute platform that could be mounted directly into the control panel. So that's pretty exciting. Now you can have, yep.
Aldo, for the drivers that aren't covered on the edge device, so you said there's a dozen or so, there's, in my experience, to be all-encompassing, you really need probably about 300 drivers altogether, right? To cover. So does that edge device talk MQTT, OPC UA? So it can be an OPC UA client against another.
Absolutely, yeah. In fact, OPC UA has been typically how we connect. And the main reason, as customers already have either Kepware or some type of OPC server, so that's typically how we connect. And the reason I bring up the built-in drivers, like for example, if you have like a standalone compressor or generator or some type of equipment that is not built into your infrastructure, the ability to connect the device directly to that through some type of industrial protocol, that's really the advantage of that. But at MQTT,
Aldo, can I jump in?
The standard.
Yeah,
go ahead.
OEMs as well. OEMs as well. So
absolutely,
drivers makes it possible for OEMs to ship their equipment IIoT ready. So Sorba IoT plug and play. I mean, that's a huge. Go ahead, Zach. Sorry.
Yeah, I want to just jump in and ask a question, and also engage the 10 of us that are listening on live, the live chat, to leave your questions down below. But so what type of systems, like SCADA or MES systems, like, the big three, or like what, or, Inductive, Factory Studio, like what type of software systems are you seeing in these architectures that use the Sorba IoT platform? Like what does it play well with in your experience?
So in terms of control platforms, obviously the big, like the Rockwells and the Siemens of the world. For the SCADA platforms, it's Ignition, Wonderware, some Factory Talk as well. I would say not as much in the Factory Talk, but those typical systems, they're designed for doing their SCADA functions. What we also like to push the concept of smart SCADA. So the ability to take this particular edge platform, and that could be in the form of a hardware or as a virtual machine. In some cases, people want to run these on computers. That edge platform, with the intelligence of making predictions and running machine learning models, adds a component to the SCADA system to add intelligence. So intelligent SCADA, we see it as a big opportunity where a lot of that data, right, is centralized. The SCADA system is really the key to a plant operations. So having that bolt-on intelligence is a big advantage for this platform.
Here's a question coming in. Why should I care about machine learning and AI? And then Walker, your question.
So the way we approach a customer is to say, well, what are some of the things that you would like to see solutions to that you cannot solve with the traditional tools today? And so the things that we get asked about is, of course, reducing downtime. And then I need to reduce my raw materials, or I need to increase my efficiency. Well, how do they approach that? You take a dashboard, you visualize some data, and you try to analyze through the person that best understands the process. They're trying to look at data and trying to make decisions based off of that data. With machine learning and AI, it has the ability to take that intelligence and to put it into an algorithm or an agent. And for example, if now I want to be able to minimize downtime, if I can model behavior of a piece of equipment and look at anomalies. So if I can train a model to say, I want you to understand how this machine normally runs. And if it sees any type of abnormal conditions, I want to be notified of it. The typical operator can only visualize so much information and process so much information with his eyes. On a paper machine, I'll take that example, you could have 10,000 different I/O points. It's a nightmare for anybody, even with 30 years experience, to understand what's going on in that equipment. Machine learning helps to give you better insight with a lot of data and a lot of moving parts. If it's a very simple machine, of course, anybody can, enough time can analyze. But when you're talking about hundreds or thousands of data points with just trillions of inputs,
I totally get it. I understand, but that was a very technical explanation, and I don't think unless you're an engineer, you're not going to get that.
Yeah, why?
It was factually correct.
Here's why machine learning and AI matter. In fact, let's not even talk about the AI part. Let's just talk about why machine learning matters. Okay. Machine learning algorithms can see relationships that the human eye cannot see. It can process a volume of data humans simply cannot process. That's the reason machine learning matters. Okay. You can take and here's a perfect example, and we'll use a consumer environment. The reason Tesla's self-driving technology matters is not so cars can drive by themselves. It's so that cars can prevent humans from making mistakes that will kill themselves. At the end of the day, every Tesla out on the road is learning how to stay safe. It's learning how to predict accidents. It is learning how to adjust the brakes and the suspension system so that you don't smash into the car that slammed their brakes on. So rather than having the car take over for you, it becomes drive assist. The car prevents you from putting yourself in a position of killing yourself. That's why machine learning matters. At the end of the day,
or your business from killing yourself.
That's right. You put a NASCAR driver next to Tesla's self-driving technology, and in the NASCAR driver with the fastest reflexes humanity can provide will never be able to perform at the level that self-driving will be able to perform at. And so the answer to that question is the reason you need to care about machine learning and AI is because your competitors will. And if you don't,
correct,
they will have an advantage that you cannot overcome through using human. Really, ultimately, at the end of the day, matters. Interesting fact. I want to drive home one other point.
All right.
You know, when Siri first came out, and we're going to do the Siri and Alexa thing. You know, we're going to, within that context, we want to kind of keep it in the consumer context. When Siri originally came out, voice recognition is machine learning. So you could walk into a room and say, hey, anybody who had a phone, who had an iPhone would respond to you, because the machine learning algorithm hadn't learned to accurately determine who was saying, hey, Siri, at that time. But now, over the course of 2 years, all my children, my wife, everyone, they try to activate my Siri, and I try to activate their Siri, and we simply cannot. That is machine learning. Machine learning makes my phone smarter just by putting my voice into it. And that's something humans cannot do.
We don't have the storage, and we don't have the ability to analyze that many variables.
We don't have the compute. We don't have the processing power. And some of these relationships, some of the relationships between process variable A, control variable B, are so tenuous. They're so subtle that the human eye can't see them. Where over huge swaths of data can identify relationships we could never see with the naked eye.
I love how
we focus our improvements on the stuff we can see. And machine learning is going to reveal to us things we can't see.
I love how you guys both answered that question. Walker, I know you had a question, but I wanted to ask, we understand now why machine learning and AI matters. We understand, the technical, components that make up Sorba IoT, but I'm curious, how easy is it to get started? What are the barriers to entry? And
I want to
hit Walker's question.
One quick question, Aldo. Will you your screen share dropped? Will you share your screen again?
Oh, okay.
Yeah, and then I want to point something out. So when people ask me, "Hey Walker, why are you so high on Sorba IoT? What's the reason that you're all excited?" The answer to your question is for me, there's you guys do a great job of talking about the difficulties of getting a machine learning program started, right? Because you've got to hire a bunch of data scientists and you have no guarantee of success, right? And data scientists are expensive. They also have no knowledge of your business. They're not controls people. They don't even know how to connect to a PLC. So you got to have a bunch of resources to do that for you. What sets Sorba IoT apart, okay, honestly, from all of everything else out there, is the fact that the brains are in the cloud, or the brains are in the platform, but you can take these edge devices here, the smart data collectors, they basically get their brains constantly updated from the platform, and your machine runs based on the knowledge that lives inside that smart. But sets Sorba apart is that you've got all this brain power. It's just that smart data collector is my Tesla on the road. It's it's learning from Tesla's machine learning in the cloud. It's sharing with Tesla's machine learning in the cloud, but it's operating on board. It's not relying on processing power that's living in the cloud. And you touched on it already, but this is something that's fundamentally different between the Sorba platform and everything else that's out there.
So it would be a good illustration to just put like Sorba and then Tesla Cloud and then like a Model 3 down on the edge, because that's essentially the architecture that you're saying, and that's how it's
correct.
Exactly.
Okay.
That's exactly it.
Because this is a little bit complicated, like your average person who's not a controls engineer is gonna just get overwhelmed by this graphic. But I understand this is a more technical like presentation, but that's my 2 cents.
Yeah, I would like to add too, just the way the industry is moving, where it all started off is building these very large cloud infrastructures, putting all this information in the cloud, taking this big data and trying to process it to create these smart models. Well, where the future is going with this technology is this edge device. It's going to be able to learn in real time. So rather than trying to collect all this information, then store it, then process it, the way the industry is going is the edge platform will take over the cloud computing. And the reason I say that is reinforcement learning, which is a way to really learn in real time online as the machine that's running is going to learn. Very similar to an infant child. How does a baby learn how to walk? Well, it tries to get up, it loses its balance, it trips, eventually it figures out how to move its legs and walk. So very similar to what reinforcement learning will do in the future is it will be able to do this real-time learning process that you won't need to have this very large infrastructure. That's why we feel that Sorba has the edge, no pun intended, but it has the actual opportunity to create these algorithms in real time. And again, the reason I get technical is because I've done this the hard way, is to code and to build code myself. And if you're a good coder, you can do it, but it takes a lot of work. And what we've done, or what Sorba's done, is to make this tool that a typical engineer doesn't have to have machine learning ability or a data science background, can build their own models to solve a problem. And I will tell you that in addition to trying to make that Tesla work on its own, the other key thing that we found in the industry is that the aging population is a big factor. A 30-year-old operator has the intelligence to know exactly what's going on with this machine, with this process. Right. Taking that 30-year-old operator and he retires, what happens to him? That knowledge walks out the door with that operator. The ability to machine learning is to contain that knowledge in these smart algorithms and keep them with the system and with the enterprise. It's huge. And then to retrain those algorithms, I mean, there's no price that you can put on that. To retrain people, to get them to understand, it's a big effort. So that's another advantage of machine learning, is to contain that knowledge, to contain that specific industry knowledge. I just wanted to point that out.
Aldo, can you go ahead and share your screen again? It dropped again.
Oh, sorry, I'm the one doing that because when we're sharing the screen, they can't see us. So if we go into a session, I stopped sharing it for you so then the audience can see us. But one question is, if there's like a link to a resource, like perhaps like of a case study of like a subtle or surprising relationship uncovered by machine learning, like an example, is there one of those? Like, we'll put it in the description below.
Absolutely. I'll have AJ.
Yeah.
Sure. Absolutely.
So before you do the actual demo, I want to go ahead and talk about a use case for machine learning in industry.
Okay.
Here is a use case, a machine learning algorithm that I wrote. Okay. The problem was we want to know when to change our tooling on our machine on our lathe. Okay. Essentially, we want to know when's the optimal time to change the tooling on our lathe. And that optimal time of changing the tooling is a function of a lot of different variables, right? What's the quality of the product that we're producing? what's the performance of the machine we're running at, what is internal temperature, and what is OEE performance, quality, and availability. So we wrote an algorithm that essentially just, the machine learning algorithm that essentially, all it did initially was just learn the relationships. It learned the machine. That is, what is the relationship between the temperature of the tooling, OEE, the number of downtime events, the quality of the parts that are being produced. And then what we did was we used that machine learning algorithm to try and accurately determine when is the best time to change the tooling when we're running this product on this machine using tooling from this vendor. And that's a use determine that by looking at all the data, spread it out on their desk and try to look at it over time. We weren't even accurate, by the way. We couldn't accurately predict tooling failure. It took almost 2 years. It took 2 years of data for us to be able to accurately predict tooling failure. And the more data we have, the more we can accurately predict it. The problem with the way we did it, and I'm not a data scientist, is that I wrote, excuse my French, bastard code to do it. One-off code that's not object-oriented, it's not reusable. I can't build another object on top of it that can consume it. It's just me building one-off static bastard code. The advantage of the Sorba platform is that because you're using the development environment that basically any engineer can create these models, they are creating object models. They're not creating bastard code. Therefore, your models can be consumed by later on down the road. And real machine learning is going to be not just the input processing output. It's going to be input processing and output to another machine learning model, to another machine learning model that's consuming the outputs from many, many machine learning models. That's the long term. The long term is that.
But not only that,
one model.
Not only that, that's why with our mission with 4.0 solutions is to get OEMs, software, OEMs and hardware, like skid OEMs using the same IoT platform for machine learning. So then that 2 years, if that's just using machines that are owned by one corporation, if that OEM implemented the same machine learning, solution across all of its, all of its customers' installations, then that 2 years could turn down into like months because, the data scales across, all of those machines, and you could basically everyone's getting better in the process. We're moving society forward to do more with less.
So I'll share with you too. Go ahead.
Go ahead, Aldo. Go ahead.
No, I was going to add that one of the things that I did, just similar to what you did, is built my own little Python script to do machine learning algorithm. I thought I had a great model, and I put it online, and it kept giving me false positives. It kept giving me the wrong output or the wrong prediction. Well, I soon found out that when you have a very high score in a machine learning model, that's sometimes not a good thing, because a very high score, sometimes you can overfit the model, and people don't realize that. If you overfit the model, what happens is that's trying to make exact replication of what you're trying to classify. And the ability for machine learning is to generalize. It needs to generalize enough that it knows the bad from good. And if it fits too much on what you're trying to classify, it eventually doesn't do what it's designed to do. So having that fine tuning or the tuning, the hyperparameters, these are all parameters that you have to know how to tune in a machine learning pipeline. That is where the challenge comes with most data scientists and machine learning practitioners. What are the best tuning parameters to give you the result that's going to give you the best prediction? And that's the ability of Sorba. It does that for you in the background, and it does all of the hyperparameter tuning for you. That is where, as a person trying to learn this stuff, I'm going, I don't have to deal with all that other stuff. Let the platform take care of it.
These guys, they're saying they want to see a live demo to see how easy it is for a controls engineer can create a machine learning model in Sorba.
Okay. So what I'm going to show you here, and if you see my diagram, the Sorba SDC, the Edge platform, is where it connects to the real world, connects to your PLCs, your IO, your historian, your SCADA, whatever the data source is. And then the Sorba platform itself, this is where we're going to train the model. So we collect the data. We then push it into the Sorba platform. We then use that history to then train it. You need history in order to build a machine learning algorithm. So once we train that model, then we take what we call the Sorbot. It's an agent, it's an algorithm that it creates, and that gets deployed back down to the SDC, and it connects in real time, ingesting that sensor data, and it's making real-time predictions. And if a failure occurs or whatever you're trying to predict, it then sends out that prediction, and then from there you can send an email, you can turn on an alarm on the SCADA screen, whatever way that you want to be able to handle that prediction. So what I'm going to show you is, let's jump into the demo. Let me see here. Okay. So on the right side, on the left side, this is the actual Sorba platform itself. This is where you set up the system. Every customer has their own tenant, so they can configure how many assets they want and how many tags and how many models. So you basically design the system through this hierarchy. It's just very similar to like an asset framework. On the right side is the actual SDC. So you can see they're both web-based. So what I'm going to do here is show you how to configure an asset and how to configure tags that will come to the actual edge device itself. So on the edge device, you see I have several assets here that I've just arbitrarily named: turbine, BFD, and whatnot. And on the platform, it will give you the same actual inputs or the same mimic of what's on that SDC. So what I do
can you show us
in
where,
here,
can you show us where it's connected?
Aldo, can you also make the web page increased zoom a little bit? Like, it seems to be
increase the actual resolution or just maximize it?
No, like just the web page on like the Chrome browser looks like it's scaled down a little bit. That little magnifying glass in the bar. Yeah, zoom in a little bit.
How about that?
Yeah, that's better for the guys watching the live stream, guys and gals.
No problem.
Yeah, can you show us where you configure the SDC to connect to the Sorba platform?
Okay, so the SDC itself, the way it connects to the Sorba platform is, let me go up here. I have to zoom it out just a little bit here. Okay, so in the right here where we have the comm service, this is the tie-in to the IoT world. So over here is where you set up what type of protocol. So I'm using MQTT, and I'm connecting it to our Sorba broker. We have an MQTT broker where it's ingesting the data from the SDC, but you can also pick HTTP or HTTPS, and it's using certificate-based, so it's encrypting the data as it gets transferred. And this is all happening as pushing, so there's no firewall issues in terms of having to open up a port to come in. So that's where you configure the IoT portion of it. You configure the Sorba itself, you configure the tags, and in the tags you set up an asset with some tag groups. And then just like a SCADA system, you set up a tag. Here I'm setting up a current, and I'm telling this tag, I'm going to pull that piece of data every once a second. And this particular one is tied to, I'll show you in the channel here, it's tied to a Siemens somatic drive. And it's got an IP address. We call it VFD as the channel name. And the tag itself is connected to that VFD channel. And there's the actual somatic address and parameters I need in order to pull the current from that drive. So I configured these tags just like I would any SCADA system. Once I apply this, the system automatically will send that data to the cloud. So in the cloud platform, I create a dashboard, and you can see here that I've got this data, and I can show you that I've got the same data popping up here as well. So I'm looking at a VFD, I'm looking at speed, the same as I'm looking here. I'm looking at a few other data points, but I can easily click and just show current. In this case, I can show current here as well. So I'm looking at the actual same data point as well. Let me just zoom that in and out. So it's a little bit lower resolution on the cloud platform, but you can see it's higher resolution on the SDC. Depends on how often I'm pulling that data. So that's how the system is connected. On the edge, correct. I'm pulling it a lot quicker. In addition to configuring your tags.
And then you're reporting by exception with MQTT?
Well, you can set that up. You can set up, yes, in terms of reporting, It's set up to send data whenever there is data in the queue. So as soon as it accumulates data, it will package it. It'll then send up a call to the platform, and it'll push that data up to the cloud platform, which is a report by exception. The actual machine learning algorithms are in this location here. So in this particular SDC, I've got about 2 dozen different algorithms. Some are predicting power. It's doing a regression model to tell me predicting power, frequency, voltage, and so on. I'm using this more as more of a digital twin. I'm trying to create a digital twin of my VFD, as well as predict anomalies and some failure events as well. Each algorithm is mapped to inputs, and these inputs are tied back to my tags, my sensor points. And I've got an output that is the output of the model that is giving me the prediction. And this is another tag, and that tag could be sent back to the dashboard, which I'm doing here. And here I'm predicting an anomaly. So this anomaly is the output of this particular algorithm here. What this big sine wave is telling me, it's trying to predict, and it's sending me a value between 0 and 100%. So it's trying to decide between current, temperature, voltage, torque, and so on, what is an abnormal condition. If this anomaly detection goes above 80%, that 80% threshold is when we send an alert to tell us there is an abnormal condition. So because the VFD is constantly moving back and forth, I've got this in a repetitive ramp up and down mode. It's trying to decide. This gauge here at the bottom, that is the same output as this, and I'm displaying it as a gauge on my dashboard. And this, you can see it's going from 51% to 60%, but it never reaches the 80%. What I'm going to have AJ do, if you're still here, he's going to go up and press. In fact, if you don't mind, what I'll do is I'll turn on the camera so you can see it's not smoke and mirrors. Let me go turn on the camera. If you can see my camera, give it a second here. Here we go. So you guys see it, AJ's pressing the drive now?
Got it.
Right there. So go ahead and press, and what you're going to see is you're going to see that anomaly. Keep pressing it, AJ. Obviously, I can't produce a bearing problem or a failure, so I've got to be able to try to simulate that. And what it'll do here, let me just click on that. Come on now.
That drive might explode.
You did press it?
Oh yeah, it's smoking.
Kyle Anderson liked the digital assets part of the presentation. Miroslav is asking about pricing, and I want to know, I'm ready to get my hands on Sorba AI, or maybe even, have it installed. Who would I go talk to?
Right now, we go through our channel partners, and the channel partner is set up to both sell the subscription. It's all based on subscription model. And the way it's priced out is based on how many algorithms or how many tags that you're processing. So it's very scalable. It could be inexpensive to a small application, and it could scale up to hundreds or thousands of models and tag points.
Hey Aldo, I was gonna ask you. Hey Zach, yeah, we could always definitely have that conversation offline. Right now, we're for those that are watching, definitely looking to sign Intellic as a channel partner for the technology. And then for those that are probably trying to wonder the relationship between ITG and the Sorba technologies, ITG just being the master channel partner. So thinking of like Tech Data, where you go to Tech Data to buy Microsoft licenses, VMware licenses. Same concept here in North America. So where eventually Intellic will be the main point of contact. What I was going to ask Aldo is if you could maybe show the audience, how do you even build machine learning model.
Thanks for that, AJ. I know some people were probably wondering because I introduced you guys from ITG Tech on our post, but I think ultimately 4.0 solutions, that's what Walker's vision is for 4.0 solutions. What were you going to say, Walker?
Well, yeah, I just want to say in terms of the pricing, when these guys first presented to us, I'm going to say 6 months ago, so on the bottom end, the pricing is incredibly competitive. So you could get started and do a pilot and get your feet wet for less than buying a Groove Epic. Okay, so I mean, we're talking small numbers here.
And that's not a stab at Opto 22 because we love Opto 22.
No, yeah, we love Opto 22. But the point is that you can get started with Sorba and machine learning for a couple
marginal cost.
I mean, yeah, marginal cost. No, and scale up as you need it, right? So as you decide you want to start deploying, you start scaling up. That's the first thing. The second thing is Sorba ITG is they're like the lead integrator. Think of it, they're the experts,
right,
at Sorba, and what they're currently doing is creating more experts.
Right, but they're also like equivalent of influencers, if you will.
No doubt about it. So Intellic integration and 4.0 solutions, our relationship is, hey, we're really impressed with this platform. We want to help you get it out there.
Right.
And if it means we got to be a channel partner and start integrating with the platform and teaching people how to use it, then that's what we're going to do. Because
right.
at the end of the day, of all the machine learning solutions that I've seen out there, this is the first one that's the total package. I mean, it's the first one that is literally the full closed loop total package for industry. It's literally the first one I've seen. And it's impressive. It's definitely.
Is there anything else you want to show us, Aldo?
Yeah. Can I show you really quickly how to train a model if we have some time?
Yeah. Yep.
So I really quickly. So let's assume that I've already collected this data. It's in the platform. Now, what I do next is I'm going to go into the training platform. So the first thing you do in the training, let me zoom this in so you guys can see it a little better, is import that data. So what you do is you create a data set and you import that data either through a CSV. So if you've got a historian or if you've already got a file, I can import it through a CSV or directly through our historian. And our historian will automatically go into the entire platform and all your assets and expose all the data. You just pick which data points that you want to pull in and it'll create a data set, a training set. Once you have that training set then you create a project. Let me point to a project here that is a training set for VFD. So in this training set, I'm going to create an analysis. These are just different analysis that I've run already. And what I do is I'll give it a name. I'll just call it analysis 1, whatever it is. I'll click create analysis. What the wizard will do, it's now creating that machine learning pipeline for you. It's already tied to this data set, which is frequency, current, power, speed, torque, and AC voltage. You can either pick these for your training model, or you can leave it as is. You can also create rules around this particular data set, where if the motor is above a certain frequency, then only train it when it's running. And a lot of times you want to train a model, you might not want to train that data when the machine's not running. So you can set that rule. If everything's okay, you click next. This is the important one here. Here's where you want to tell the system, what am I trying to do? There's 3 types of machine learning types that you do. Clustering. Clustering is what you do when you have unlabeled data. And what I mean by that, if I want to be able to learn what is the anomaly, what is the normal behavior of that machine, and try to highlight for me problems and anomalies that the algorithm can find. That's what clustering does. It's trying to group the data in these clusters that will try to highlight what are those outliers in that data. And the other one is classification. Classification is when you're trying to train the model on a specific event, be it's a failure event or a quality event or some type of event that you wanted the algorithm to learn. So that classification in supervised learning world, you have to specify the response variable. So you have to go into that column and put a 1 in all those records that you want the algorithm to train. You don't have to do that with this. You just import the actual event, whether it's an alarm event or a work order. And what the system will do is it'll mark the data at that point in time that the alarm occurred, and it'll train it on that alarm event. So if I have, 100 alarms, I can tell the system, train it on those specific alarms and try to learn what those alarms are. And so if I pick one of those, it'll be able to train on that. Then the last one is regression. Regression is where you're predicting an output. So if I want to predict what is my OEE, or what is my efficiency, or what is my production rate, regression is a way to create a variable output prediction. So those are the three. What's interesting here with the platform is that you can either pick an algorithm from here or leave it an auto select. Let the system decide what is the best algorithm, what are the best hyperparameters. I don't have to do anything. Just click next, and then it's training. So right now it's doing all the heavy number crunching, all of the auto tuning hyperparameter. And what you get when this thing is done, it usually takes about, depends on the data model, depends on the data, could take anywhere from a few minutes to a few hours, depending on how large a data set. That's really where most of the heavy lifting is. At the end of the model, at the end of the training, what you get is here's your raw data. So that VFD is cycling up and down. And what the model will do is it'll try to find those anomalies. So this anomaly score, what it's telling me is that this 60 or below 60% is a normal condition. When it starts to peak above 80, that's telling us, aha, it found an anomaly here. So what I can do is zoom in to that particular anomaly. And what you'll see in the waveform, you'll kind of see it gets a little distorted, and you can see a little distortion of that waveform. That could be me holding the shaft or tapping on it, whatever the case is. It was able to highlight that anomaly. And so, in this
can you zoom in just a little bit?
World,
can you zoom in just a little bit on that trend? It looks, I could see it from here, but I just want to make sure everyone gets a chance to see it because this is what they were looking for.
Is that better?
Yeah, that's good.
Okay, so this particular anomaly that the algorithm discovered, if I have to do a couple things, I got to determine, is this an actual problem on my machine? So there needs to be some validation or feedback from the operators, or if this could be tied to an alarm or a work order. If it is, I want to say, okay, let's train that. I'm going to pick a point on that anomaly, and what it's going to do is going to go directly and create an event, and that event will be tied to that point in time that I'm going to train, and it will train that model, and it automatically says, let me look at a day before that event occurred, and I'm going to train on that. And so what ends up happening is that you get an output that is trained, and at that window that it's trained on, it provides you that score. That score is the confidence level that this model, the supervised learning, was able to predict that particular classification. So in addition to giving you the score and the probability of predicting that classification, it also gives you a tag ranking. That tag ranking is what we call a contribution to that particular event. What is the ranking of those tags and what was the problem? Almost like a root cause analysis. If I want to know what particular input or sensor point was the root cause of this particular downtime event, this is what you use to determine that. We can do things like drives. I'll show you one here that was tied to oil analysis. This is one we did for NASA. NASA asked us to do analysis on their, they have these flywheel generators, and they had 3 vibration inputs. So these vibration inputs were analyzed, and they were analyzed over time. What I did is I also included the rate of change. So I included the rate of change.
Excuse me, did you say NASA or Nassau, like the island in the Caribbean?
No, Nassau is in the Cape, the Kennedy Space Center.
Yeah,
I'm sorry. Maybe it's my redneck pronunciation. Sorry. It is at the Cape here in Florida, where they have these very massive generators, and they're flywheel generators. In the event they lose power, they were having issues with this particular generator. This is what it looks like. they have these three vibration accelerometers, one on the base, one on this coupling, and one in this bearing here. And that's what we're analyzing. Those three inputs is what it analyzed. And what the algorithm came back is it found these anomalies. And as you can see, some of them were pretty obvious here, but some of them might not be so obvious. And so we trained it on these specific anomalies. We're able to determine those events and when those events will occur. And what you get is a prediction point of when that problem occurred. So that lead time before failure is the model will predict when did that problem start. So now you will get an alert to tell you, hey, 2 weeks before that vibration sensor became hot, I could tell you that within 2 weeks or even a month before it actually starts. The beauty about machine learning, just using three accelerometers, it's very simple to predict that because you're measuring the amplitude or the FFT of that vibration. You can determine that. But what if I added current? What if I added pressure, temperature? If I added other process parameters to this algorithm? Now I can predict that much earlier because typically you will see some type of correlation back to the process that you can predict that much, much earlier. For example, did I lose?
Aldo, I had to cut you off because I know Walker has to go here.
Okay.
Unless Walker,
no
you're able to stay for longer because I mean this has been an amazing demo so far, and I really like that NASA example.
Well, I mean, one of the things that Aldo hasn't talked about is, who's using Sorba. I mean, so and where did what use case? I mean, the train use case, that's your bread and butter, right? I mean, that's Sorba's claim to fame, right? If you
correct.
Give a couple of examples of people who are using. I mean, Sorba didn't just fall off a turnip truck. I mean,
real quick question from Ron Daffo. He wants to know you guys are using Google TensorFlow, which I believe the answer is yes.
Yes, correct. So we do use open source libraries like TensorFlow. We use sklearn and some other ones, PyTorch, that are standard libraries that you can implement. So, but again, the beauty about that is that's behind the scenes. You don't see that. If you want to build your own algorithms, you can also import your own machine learning algorithms if you want to be able to customize it. Right. But that's, again, the data science world. You don't have to know anything about that. It's all done for you behind the scenes.
Another good question.
And I was going to add to that real quick, Zach, is that pipeline that Aldo's talking about, right, in terms of selecting the tags. Actually, the Sorba machine learning pipeline is actually a multitude of different algorithms. You have algorithms focused on selecting or pre-processing the data. You've got algorithms dedicated and focused on selecting the tags. And you've got algorithms a part of that pipeline as Aldo's showing you the output, that post-processing of the data. So it's actually a bunch of algorithms that are working in unison to one another to get you the one output that you're looking for.
And I just want, Zach, before you ask the question, I want to drive home a point here. So for the viewers, why Sorba? This should be the question. Why Sorba? And to the person who asked about, are they using Google TensorFlow? Yes, of course. Why? You definitely want giants, right? That's the whole idea. What sets Sorba apart is that all of the things that I can do with just a couple of clicks of the mouse in the Sorba platform would take me weeks or months to do manually in Azure or AWS IoT Hub. I mean, if I'm going to build that from scratch, it's going to take me weeks or months. And in Sorba, I can do it with a couple of clicks of the mouse. One of the things that I learned here that I did not know that we had the ability to let the platform determine the optimal algorithm methodology. Regression, for those who are new to machine learning, regression is probably the most common in industry, where we're trying to predict, we're trying to monitor values to predict a future value, right? That regression, whether it's linear regression or not, that's probably the most common. But what Sorba is different is that there's this environment where non-data scientists can essentially do in a few clicks of the mouse what it takes data scientists weeks or months to do manually.
Because that's probably where that question was going, or maybe he was just curious of the underlying technology. One last question from the audience is, you showed us the tag output path for the predicted failure event. Is there a path to get from the system remaining time to failure for unsupervised learning case?
Ooh, that's a good question. Very good question.
Remaining time to failure for unsupervised learning. What you have to do if you want to, if you're talking about being able to predict the anomaly, if I'm understanding the question.
And have the remaining time until that predicted failure in advance.
As a tag.
Okay, so and that is a tag. So that remaining time, it also becomes as part of that package that gets downloaded to the SDC. You have your yes, correct. You have your time of the prediction itself, as well as you have also the remaining time to failure. So what we call is the remaining time to failure is a tag that gets outputted back to the machine learning model.
We should definitely do this again. Walker, do you have any, what else do you want to?
Well, I have a couple. Yeah,
we can keep going if you have time. We can keep going.
Well, what I would really like, honestly, Zach, what I'd really love to do is I would like the community to stew on this for a couple of days. I want to read the comments, and I want to see what people gravitate to. What are the questions that the community keeps asking over and over and over again, and then we should do a follow-up where we address those specific use cases, those specific questions that'll give us a chance to clarify. Because I honestly, the truth is there's way too much to cover in 1 hour.
Correct.
We just barely scratched the tip of the iceberg here. Well, ultimately, what I wanted people to get away from our audience to take away from this is when we talk about Sorba IoT as a best-in-class solution, I wanted to highlight what sets Sorba apart.
Yeah. So is there any digital courses on digital courses on how to learn Sorba available?
Well, I was going to ask the question, where do you learn how to use Sorba? Yep.
AJ can answer this, but we do have some YouTube training videos that you can access online, and we have some documentation. That's what we have today in terms of public domain training material.
With the multiple applications, right, of the platform, Zach and Walker and those that are watching, we have training videos on the SDC, how to configure a box, configure your tags. We have training videos on how to create an algorithm, some of the best practices, because that's really what it is, right? If you're going to come from a controls background to this world of data science, machine learning, you definitely want to follow best practices. And again, to really make sure that when you are ready to go live in production runtime mode, that you got the confidence that you need. So yeah, all of that's definitely in the development, definitely in the making. So be patient with us. But again, the whole point of what we'd like to accomplish this year is to make sure that, even with that training, with that knowledge base, that Intellic would definitely be leading that charge.
AJ,
can I address your question? Go ahead.
Aldo, go ahead. Yep.
I was going to just address your original question of use cases, just to quickly identify a couple of really important use cases that I think it's noteworthy. Is we're looking at a paper machine, as I mentioned, 10,000 inputs, almost 1,200 vibration sensors, and what the whole idea was can we build a model so that the intent was, can I predict a problem with that paper machine that would give me some kind of leading indicator? And not getting too complicated in the technology aspect, we're trying to reduce downtime. And a paper machine, that could be $30,000 to $100,000 an hour in lost production time. So it's very important for this model, if it can predict a problem before an alarm or before an actual downtime, that's the key. So paper machine is one area. Another area which I think is very noteworthy is optimization. So we're currently working on a project with 5 boilers, steam boilers, and the objective of that project is to determine, can we stabilize the steam and can we reduce the amount of fuel consumption? A 4% reduction in fuel consumption to this customer is worth millions of dollars. So if I can take machine learning model, learn the behavior of those steam boilers, and then find an algorithm, an optimization algorithm that I can run to provide what are the optimal settings, and then in real time be able to predict that and make those adjustments as an advanced control, as an advanced process controller. So those are two really significant use cases where the payback, the value is extremely high.
So AJ, real quick, can you getting started? Right now, obviously Sorba has gone to market, and for the new user of the Sorba, what is the biggest challenge to getting started, in your opinion?
In our opinion, really, it's just understanding their pain, right? Understanding their business. So we can talk about the technology all day. We can talk about how great IoT and machine learning is. But if you don't really know the problem that it is you're trying to solve and all the metrics and different different steps leading up to that point, it's not going to matter. You really have to understand your problem and your business, and how is this technology going to augment that and help you solve this problem, number one, at scale and then quickly. So that's, to us, we see a lot of customers like, well, can you help us define that for us? When in all reality, I can't go into your ERP system. I can't pull up all those metrics. It's really up to you to define what it is you're trying to do and accomplish with this technology.
Yeah.
And you've heard of the concept of digital twin.
Yeah.
This is an example of a digital twin where we're predicting all of the different attributes of that motor: frequency, power, speed.
Aldo.
Oh, I'm so sorry.
Yep.
Yep. Where was that sucker again? Hang on a second. Here we go. Yeah, here's an example of a digital twin. Taking that same motor and trying to predict all the different elements of that motor: current, torque, frequency, voltage, AC and DC, power, speed. You can see from this model here, I've created a model. Look at this, is the real-time frequency, and I'm predicting the frequency as well. They're almost identical. So this model is able to understand how does frequency behave? How does current behave based on different input parameters? And then taking that concept, and I'm trying to determine what is the optimal speed to give me the lowest power consumption. So this is a very simple optimization, but the key here is having that digital twin.
It's incredibly, but it may be simple, but it's an incredibly valuable.
Mm-hmm.
Huge.
Incredibly valuable.
Right.
And
absolutely.
Yeah.
Walker, I'll make one more point. You asked, what are some of the difficulties? What I do appreciate, Zach, and what you guys are doing is, number one, I think it's a lot of this is with management, right? So managing these expectations, starting on a small scale, and having a repeatable business case you can replicate. And talking about your OEM concept, that is huge. So people want to boil the ocean, where our focus, and again, having the integration background, is where can we come in within a matter of a week, 2 weeks, help you get started on this digitalization. I think correct. Show value.
All right, guys, I gotta end the live stream here because I want to respect the viewers' time. But Aldo, that was an amazing demonstration, man. And AJ, thank you for
very much.
Coordinate it. Walker, you want to close it out, man?
I do. I want to thank. I really want to thank you guys for being flexible with the time today. This was supposed to happen earlier in the day, but because of my schedule, we had to move it. I really appreciate you guys taking the time to do this demo. This has been more than a month in the making, trying to put this together. So we really, truly appreciate you guys taking the time. Next steps, I definitely want to do a follow-up to this. So I think it's really important for the community to ask more questions. What else do you want to see about the platform, so that we can do a more focused demonstration? Because I assure you, Aldo barely touched the surface here.
Oh yeah.
So and that's really what I'm looking forward to, is the presentation. But I think this has been invaluable. I'm really glad we did it. Thank you very much.
And guys, if we did not answer your comments, we're sorry. Just leave them in the actual comments of this YouTube video, and maybe share it with a colleague, and we'll get back to them. We promise. So we'll see you guys in another episode of the Intellic podcast. We'll see you guys soon. Peace out.
Great. Thanks, guys.
Thanks, guys.
Thanks, guys.